Yeah, is it okay now?
Yes, please.
Okay, so students, distinguished panelists, and my fellow colleagues, good afternoon and a very warm welcome to this exciting webinar on unlocking the career frontiers, the physics advantage. We are thrilled to have you join us today as we explore the vast array of career opportunities that is available to physicists. So it's often said that physics is the cornerstone of understanding the universe, but its application extends far beyond the academia. We are privileged to have a wide varieties of panelists, distinguished panelists, who have leveraged their physics background to excel in their respective fields. So what makes physics so advantageous in the job market? It's a trio of crucial skills that it imparts. The number one is the data handling, number two, coding, and the third, the last one, and but the not the least one is the modeling. So these skills are not only valued in the traditional scientific domain, but are increasingly sought after in very wide range of industries. So as we dive in discussion today, I hope that you will be inspired by the journeys of our distinguished panelists and gain insight into the principle of how the principles of physics can open doors to numerous career paths. So thank you all for being here. Without further ado, let's begin our discussion. Now, it is my pleasure to invite our esteemed Dean, Professor Dr. Bimal Kumar Sarkar, to present his welcome address. Sir, over to you.
Thank you very much, Dr. Mukherjee, for your kind note and word. And really, today, the right time to express the multidisciplinary nature of physics. That is very important. And also, it is realized that not only core physics will be contributed by physics, many other fields are also applicable with this core subject physics. Not only the example is sufficient that we know that from 1950s, the DNA inventor was one of the person from physics. We know this one. And not only that, that is core science. Even if we talk about the application of physics in other domain, which is not exactly covered by science. For example, if we talk about very recent, I have seen somewhere that they are asking to study the economic world with the help of some physics model. They are calling that the application of kinetic exchange model of markets. There, they are applying the concept of different physics phenomena, which generally we do, to be applicable in the field of economics. And that model was given name as kinetic exchange model of markets. It is in economics. What they are doing there, I have seen, they are asking physics person. What they are doing, they are taking the kinetic theory of gas model to be implemented in case of economic dynamics. Number two, another example can be given in ready-made in hand, that in political science, some person was asking that they need the proper physics concept to be applied to know about the shifting of political epicenter from European to Chinese, East Asia like this. They also need some kind of conceptual physicist person. So why I'm giving these examples? Just to explore and to open in front of the forum today that so many things, so many cases are there which can be handled by physics person. So that our idea should not be confined in the domain of physics activity, also can be applicable in other fields also. And based on this, today, in the right moment, the Department of Physics at Adamas University is organizing this panel discussion that different scope mainly for the establishment, accomplishment in professional life for the physics person. This right moment and very relevant today will be discussed. And it's very pleasure for us and fortunate we are very much that a group of people who are basically physicists, but they are contributing to other fields. And I'm quite sure today, very interestingly, very effectively, they will enlighten much. They will enlighten much today's discussion. And rightly, the Department of Physics is conducting today this discussion session. And I welcome each and everybody to this forum today. And I wish a grand success with grand outcome of today's discussion. Thank you very much. Over to Dr. Mukherjee.
Thank you very much, sir, for your insights. So now I feel it's imperative to familiarize with each other. So to do this, since we are new to our students and the audience, so I'd like to request our head of the department, Dr. Momita De, to tell us briefly about the physics department of Adamas University.
Yeah, sure. Am I audible clearly? Yes. Okay. So thank you very much. Professor Shortkar, Dean sir has already welcomed all of you. So good afternoon, everyone. A very warm welcome to this enlightening panel discussion. Actually, I'm delighted to welcome you, all of you, to this panel discussion, which particularly put the focus on different career aspects of physics, what we can do after studying graduation or post-graduation in physics. In fact, we have started this very recently. Few weeks back, we have organized another panel discussion, which was on a different aspect of physics, which is the medical physics domain. And today we are organizing this panel discussion, which will be, I am very hopeful that it will be helpful to the students. And here we will be mainly focusing on the different aspects like academia, research, and most importantly, job aspects like machine learning and data science. What is the market for that? What's the requirement to be a person in that domain? Finance, etc. So I am hopeful that students will be very much informed, and this discussion will be very fruitful for that. So now, as a head of the department, I wish this event was conducted in offline mode and you all visited our university. But many schools, there is summer vacation going on in many colleges, the interim examination is going on. So that's why we thought that it would be better if we organize this in an online mode so that at least everybody can join.
Thank you very much, Dr. Dev. So we are going to start our discussion now. In our first discussion, I would like to introduce you with two astrophysicists. One is Dr. Luca Naso, and the other one is Dr. Rakesh Mazumder. So let me briefly introduce you. Uh, s- so, so our first guest, Dr. Luca Naso, is a multi-talented professional. So as you can see, he did his doctorate in astrophysics, then move on to the field of data science. He's now data innovation manager at Etna High Tech. And apart from his interest in data science and astrophysics, he's also avid marathon runner. So welcome, Luca. It is our privilege to welcome you in this panel discussion. So our second guest is Dr. Rakesh Mazumder. He's currently the physics curator of Birla Industrial and Technological Museum. So Dr. Mazumder did his PhD from IISER Kolkata, then did his postdoctoral studies in Indian Institute of Astrophysics and also in Aryabhatta Research Institute of Observational Sciences. So welcome, Dr. Mazumdar.
Thank
So we are honored to have you. So let us start our discussion. So in our discussion, we'll be joined by Dr. Luca Naso and Dr. Rakesh Mazumder. So Luca, am I audible to you?
Yes.
Okay, great to have you in today's discussion. It's our privilege to welcome you. So
Thank you very
let
much.
me begin by begin by asking, could you give us a quick recap of your journey so far?
Yes. Okay. Well, first of all, again, thank you very much for inviting me here. I'm excited to be here and see that there are so many people connected. So I always enjoy to share my experience, especially with students, hoping that they can benefit from my experience. So as you said, I am an astrophysicist. So I graduated in physics in Italy, and then I did my PhD in astrophysics, still in Italy, but at an international institution. And then I worked as a scientist, as an astrophysicist around the world. I worked in Poland, I worked in UK, and then I also moved to China and worked in Beijing. Then I moved from academia into industry, and so I left the world for which I studied and worked for so long to move into a new world, which is the world of business, if you want. And my main role was data scientist. So I started working in academia as a data scientist, and that started about in 2013, so more than 10 years, when I made this switch. And in these latest 10 years, I have done a lot of activities. So I work as a data scientist, but also then I was a CTO and a CDO, like Chief Data Officer. I work as a product development manager. I've been a mentor for startups. And I've also been a teacher and a professor in different places, universities, high schools, for training professionals. So in other companies or enterprises. And as you said, I have also like other passions like running and outside of the strictly saying like a professional life.
Okay. So what are the core duties that you perform in your job?
Okay, yes.
What are the core duties?
Yes. So this can be a very long question because today I do a lot of things and they can also be a little bit different.
Yeah, just keep in mind that you are speaking to students, so I mean that just
Yes.
so that they can understand. Yeah.
Yeah, absolutely. So on one side, I work to try to find new ideas where data science can bring a great impact. So at EHT, we think about new projects. We apply for these new funding for these new projects, and these projects have a very broad impact. EHT works with a lot of fields like health, energy, environment, and so on. And in all of these topics, data science can have a huge impact. Now everybody is looking for machine learning, AI, Gen AI, big data, and so on. Everywhere there's a lot of data, and so I try to think about how data can be meaningful within each context where we operate. But at the same time, I started my own company. And so in my own company, I'm an entrepreneur. And so I'm in charge of setting the strategy. So I have to try to understand how the business can improve, how can develop. And at the same time, when it's a startup, you also have several duties that are not directly connected with your position. So in this case, I have to provide scientific and technical guidance to the people developing the solutions within the company. And right now, I'm not doing any coding. I've been done that in the past, but now I'm in a phase where I tend to give directions so that others can bring the coding forward. And not because and they are better than me in doing that. So because it's hard to keep pace with everything. So as you move on, you try to focus on some activities and delegate the others to other people. so that overall you can grow better. It's the same as also in physics. I think no paper is published by a single person. You always try to collaborate so that everybody can do something, and all together collectively you can progress faster and better.
Surely. So in this context, so I would like to ask you your background here, other in your current role as entrepreneur, data analyst, everything.
Absolutely, yes. I think that although in my scientific career, I never studied how to make a company, how to run a company, how to close a lead, how to win a customer or make a lead. All the rest I have studied helped me.
Yeah, please carry on.
Okay,
Yeah.
sorry.
Yeah.
So I think physics helped me in developing the number one skill, I think, in my personal experience, you need to succeed, which is critical thinking. So being able to analyze what's around you with your own head. It doesn't mean you're right. You don't have to question everyone, but you have to understand what's happening. And when you don't understand, you ask for help. When you do understand and there's a mismatch, you ask for a justification. No, you try to understand why, or you make a suggestion, you make a proposal. So critical thinking is something that physics certainly has helped me with. In addition, there's, and I think someone mentioned this earlier, this skill about modeling. So for me, modeling means being able to apply critical thinking to what's around you, but then go to a higher abstraction layer to try to understand what's happening and why it's happening. So create a model of what you see. And with a model, then you can make predictions and you can understand things that are not happening yet. So you can become a visionary. But it doesn't mean you are having an hallucination. It's a vision based on a model, so based on an idea. Is not the same model that you have in physics, because that's a model of how nature works. Here, I mean, in business is a model of how you can create value for other people.
Okay. Thank you very much. So there may be some few questions from the audiences as well. So please be with us. So let us now move on to Dr. Rakesh Mazumder. So Dr. Mazumder, are you here with us?
Yes, I'm here. And I
Yeah.
think
So tell us briefly about your journey so far, sir.
yes. So I started my journey from a small remote village. It's somehow near to Adamas University. It's called Awal Siddhi, and the school was a village school. It is Adhata High School. So I did my schooling from 5 to 12 from there. And at that time only I decided that I'll do something in physics. I remember one day, like I went for a tuition, and this teacher told I'm full. Then I asked him, sir, I love physics, I want to build a career in physics. So that time I was in class 11. So he said, you are not too early. I told, no sir, I'm determined that I will make a career in physics. So after schooling, I finishing my schooling, I went in Narendrapur Ramakrishna Mission for B.sc in my physics as a physics major. And after passing out, I went to IIT Madras as a M.sc in my physics. And then I moved to IISER Kolkata for doing PhD in astrophysics. And then I completed PhD, and then I was doing postdoctoral research. And then I did not had any idea that a museum could be a place where I can play some role. But one of my friend actually joined. I came to know next year. I given the exam, and also I usually try to interact with her, my friend, that how is what is the job role in the museum and how is it. And then I started liking it. And basically the job is a science communication. And then I just loved it. And after joining, now I joined in 2020. 2 years is past, and I loved it. It is fantastic. I am finding their scope to do astrophysics, not only research, but in form of science communication. I did it earlier during my M.sc or during my PhD time as a outreach activity, but I never thought that will be my career at that time. That time I did it just out of my interest, and that will be my suggestion to the students as well. Always keep growing your interest in any field you are finding it interesting. Keep doing more about it, keep digging, and then you will find one day you will find something to do which is you find interesting. And if that you do, then whichever field it is, not only physics, in any field, if you do something which is out of your interest, then you'll be doing good over there. Yes.
Yeah. So is there anything particularly exciting happening in astrophysics that our students should know about?
Yeah, a lot happening astrophysics nowadays. So
So one or two maybe you can
yeah,
discuss
yeah,
here
I
with our
can
students.
discuss.
Yeah.
Sure. So recently, after the moon mission, Chandrayaan 3 mission, everybody knows we are excited like a cricket match, whether we'll win with Pakistan or we'll lost, like that, whether we'll be able to land or not. So after this Chandrayaan 3 mission, immediately came Aditya L1. So Aditya L1 is a mission dedicated for the solar to study the solar physics, to study the sun by the Indian, not only ISRO scientists, but also other universities and other research institute in astrophysics in India. So the payload, scientific payloads was built by them. So this will be a great opportunity. Like when I did my PhD, I used some data of Kodaikanal Observatory of India and other satellite data I use, that is of NASA and other observatory of JAXA, Japanese Space Agency, and other space observatory like ESA, European Space Agency, all those. But now India has its own observatory, and there is opportunity for physicists mainly, and there are opportunity for others discipline also. So to use this data, make out some science out of it, and that is one thing. And another is National Large Solar Telescope, the largest solar telescope that is also being planned uh, by Indian solar physicists, and also maybe 30-meter telescope, which is not only India but a total all over the world from scientists
International
from all
collaboration. Yeah.
international collaboration. People are coming, and they wanted to build the largest telescope in the world. So that will bring that huge amount of data and information for analysis of which machine learning and data analysis, like data science, that will be important. And so keeping eyes on the future, astrophysics will be one major game player in the job market also, and in the science also in future, that I think.
Yeah, so our students get this flavor that while doing research, they are get introduced to big data, big amount of data, how to analyze them using intelligence and machine learning. So that is part and parcel of physics now. So and that can help to find job in other sectors as well.
Yeah,
So
yeah.
students, please take note of these things. Yeah,
I know a few of my friends who are doing physics. Like I came a little bit offbeat way, not in a. Usually, people think after PhD, after postdoc, people will be a lecturer in some university. So my own way was little different, and also I know a lot of my friends. Like one of my friend did his PhD from Bose Institute in the quantum computation. He did not went for even research. In immediate after that, he got a lucrative job opportunity in the industry, and he joined there, and he's enjoying as a quantum computing and doing a good job there. So like that way, I know a lot of thing. And astrophysics, I know from in Adamas University, you have a course also. And I was talking with Papia, and we are just discussing one student who went to KU for doing
yeah.
research in astrophysics. So you find that opportunity in Adamas University and ISAR Kolkata, and Center of Exchange Space Science in ISAR Kolkata, and also like Post Institute Astrophysical Physics is their Presidency University. They have also introduced. So a lot of opportunity in West Bengal, and also other like Indian Institute of Astrophysics, IUCA in Pune. So there are a lot of places outside as well, but if you don't want to go or don't get an opportunity, there are good opportunity, equivalently good even opportunity to do physics and astrophysics in India itself.
Yeah, thank you, sir. So let me go back to Luca now. So Luca, so suppose for example a student want to make this transition from academic sector to data science or data analysis part career. So what are the must-have skills you would suggest they should have?
Okay, so it depends at which level you are doing this transition. So if you do it after master or after PhD or after you are already a scientist. So of course, the longer,
so
the more skill you should
better.
have. Yeah.
Yeah.
In general, I
so-
think I think that it also depends for which position you're applying. For sure, if you want to be a data scientist, you need to know the technological part. So you need technology. And technology today doesn't just mean coding. Usually, if you go out from physics, you know to code very well, because today, like, numerical simulations is everywhere. So maybe you know Python or C++, but that's only part of the game. The other part is cloud. So you should also be familiar with cloud. And but of course, I mean, I mentioned all of these. Probably you don't need all of them, because the question is generic and data science is a very broad field. So you need to know something about technology, but maybe there's a company who doesn't use cloud. It's very difficult. They are very small. Everybody uses cloud, but maybe your role will not have to use cloud. But if you know, then you know better how to integrate. So the technological part is usually a must have. That can be coding and cloud. And on the other side, as I was saying before, like some critical thinking, you need to understand what you're doing. You need to understand what it means to make a predictive modeling, what it means to build, to train a deep learning architecture to classify one image. Even if you don't know how it works because you never studied it, that's fine. But you should get an idea of the whole procedure, like the whole process, how it works. And knowing your weaknesses is actually a strong point. So you don't need to know everything, but you need to know what you don't know. So I don't know how to build a deep learning neural network. That's fine. Just say it, and it's absolutely understandable that you don't know that part. So it's good, because if you know, you will not try to make it, and then you can create a problem, a major issue.
Thank you very much, Luca. So I know you are a busy person, but you squeeze out time for us. So we are very thankful for you. So thank you very much for joining, and have a nice day.
Thank you very much. I'm really very happy to be here, and I encourage everybody, if they want, to connect with me on LinkedIn. I mean, you publish my picture that's coming from LinkedIn. I'm always happy to share and help people when I can. But also with your department,
Great.
I've seen the presentation. You do amazing things. So we can keep in touch and see if there can be room for collaboration. In fact,
so maybe some of our students can do internship in your companies as well, online maybe from.
Yes, I mean, actually, I had some previous experience with foreigners in my company, and from Iran, and also from India, and also Italian people. Usually, we are a mainly remote company. So even if they are Italian, some work from UK, other works from the rest of Europe. So I'm open to connection. I love to share. I think that we are together, we are stronger.
Great. Thank you very much, Luca.
Bye, everyone. Thank you.
Bye.
Have a nice day.
Bye.
Yeah. So let us move on to Dr. Mazumder. So Dr. Mazumder, so my final question is this. What are the career opportunities available for an astrophysics? Just briefly, I mean, you have already said things in your introduction, but
yeah. So path straightforward is you do PhD and do postdoc, and then you do a researcher in a research institute, or be a teacher in some universities, or in ISARS or institute like that in India and also in abroad. That one opportunity I want to tell and share it with you. A lot of my colleague or a lot of my friends and a lot of my seniors during my PhD, they now settled abroad and they are doing very good job over there in astrophysics. So that could be another opportunity. And another opportunity, since as I told already that there is a big data and data handling portion in one part of the astrophysics. So there could be people who do a lot of data analysis in the astrophysics. They have a opportunity to become data science, and not only in astrophysics, but they can do analyze the data wherever in industry, wherever in the banking sector, and everybody nowadays people are using a lot of this data analysis skill like machine learning, AI already as you told. So that can be a career as well. And as a science communicator, you can also join museum, science museum. So I work in Birla Industrial and Technological Museum, and it is the oldest science museum in India. And we have also our museums under NCSM, Salt Lake National Council of Science Museum, other museums all over the India, like in Pune, in Bangalore, in Mumbai, we have in Delhi, and also we have our regional centers in Bardwan, in Digha, in Shiliguri, in Purulia, like that. And as a science communicator, I love to do this job because we get to interact with the student, convey the science to the society, not only students, but for the other people who make science models. And I like to invite Adamas University's faculties and students. Someday you can visit BITM. Your student will going to love it, that I promise. So there are a variety of opportunity in the career of astrophysics. But one thing is for sure, that it gives, along with the astrophysics knowledge and all other knowledge like data science and all, one attitude to you, that is problem solving attitude. That is important. Even if you become after doing B.sc in physics, you give some exam of like civil services and become a WBCS officer or someone, you'll see that how a physicist see the world and try to analyze what is happening. That attitude, I realized that during my MSc and also during my PhD, that the whatever job you will do, basically you will solve the problem. Problems is will come, and you have to find the solution of the problem. So if that attitude can be built up, then you can excellent in any sector, any place. Yeah.
Right.
Thank you.
Thank you, Dr. Mazumder, for taking out time to join us today. So it's a pleasure to have you.
Thank you, Dr. Mukherjee. So welcome once again, all of you, to our this special event. And in this second session, we are joined by two of the most esteemed experts in the field of physics from renowned institution. Our first panelist in this session is Professor Prashant Shukla from the Bhabha Atomic Research Center, BRC. He is a scientific officer H at the Nuclear Physics Division of BRC and heads the Theoretical Nuclear Physics and Quantum Computing section. And recently, his focus has shifted to quantum device simulation and fabrication on superconducting platforms. Our second panelist in this session is Professor Anjan Barman, a senior professor at the Stellenbosch National Center for Basic Sciences in India. Professor Barman is currently working on the cutting-edge research in condensed matter physics with a focus on nanomagnetism and spintronics. He has been recognized as a fellow of the Institute of Physics, UK, and the Indian Academy of Science, Bangalore. His national and international recognition include the MRSI medal in 2017, inclusion in Stanford University, top 2% most influential scientists list, and many more. So I would like to request first of all, thank you, Professor Shukla and Professor Barman, to join us. And I at first want to request Professor Shukla
Can you please briefly describe your journey from being a physics student to your present role actually? Sir? Sir, can you please unmute yourself?
Yes.
Yes.
Okay.
Sir, am I audible to you?
Yeah.
Okay.
Just some setting. Okay. So first of all, let me thank the organizer for this invitation, and it has been very interesting to listen to the not only for the students, even for us to listen to this experts in various fields. And okay, so let me now come to the question which has been asked. How my journey from a physics student to this place. Basically, I have done my physics M.sc in physics from Uchen. This is Vikram University. This is in Madhya Pradesh. There itself, I was from the school days itself, I had interest in physics. So physics and mathematics, these were my favorite subjects. So at that time, I was aiming for a physics job. That was my top priority. And then after MSc and 1 year MPhil, then I did. Then I faced this exam of Bhabha Atomic Research Center. There is an annual exam which is called training school. Now it is called orientation course for engineers and scientists. So every year BRC takes recruits scientists after MSc and BTech. So this is one of the very few opportunities where you are directly absorbed after your MSc or a BTech in any engineering discipline. I have done my PhD after joining BRC. So after a year of training, then I was appointed in a nuclear physics division. In this division, I had done low energy nuclear physics. So there are low energy nuclear experiments in our country in hundreds of MeV energies. I also did a lot of theoretical work. Then actually I have moved to higher energies. So for higher energies accelerator, we participated in Brookhaven National Laboratory. There's an experiment called Phoenix in Brookhaven National Laboratory. So that is a 200 GeV of collision energy. Then CERN, I think that all might have already heard about CERN experiments. So CERN is a center for European Center for Nuclear Research, and BRC has been a collaborator for a long time there. So we joined a CMS experiment there. Our main job was to do this lead collisions where we create very high temperature conditions which are suitable, which are actually existing in early universe. Probably I will explain that more if you ask later. Also, we participated in this discovery of God particle. But our main work has been in this quark gluon plasma. I will explain it later. So for last 3, 4, 5 years, I have been active in this quantum computing devices development. So that's where now the focus is, and I have been anyway doing a lot of theoretical work in nuclear physics, high energy physics, as well as doing this um, quantum computation. So that's how it is.
So thank you, sir. This is wonderful journey. And since you were talking about the late collision, and this is from Alice, I guess. So can you?
From the CMS, we were part of CMS experiment.
Okay, you are.
There are 4 parallel experiments.
Yes.
So, yeah.
So can you please elaborate or give some example of the collaborative projects that you are leading or been a part from the B.sc actually?
So from BRC, we had no, about CMS from for
No,
this experiment.
actually the many different example of the collaborative project that you are basically a part of as a member of the BRC.
Yes.
So
as I had told that we were in this Brookhaven National Laboratory collaboration in US and the CERN collaboration. Before that, we also had one collaboration which is called COSI JM collaboration in Germany.
Yeah.
And actually, I had done my postdoc in Heidelberg. That time I was in Alice collaboration, so I was there.
Okay.
2 years in Alice also.
Yes.
I have been also part of INO collaboration in India. So as you can see that most of my time has been in the international collaboration.
Yeah. So this is really very good actually. Our students may find interest actually. Some of them always asked me to how to join this collaboration, and that's why. So I think they're really thrilled.
For that, basically you have to join institutions
Yes.
where some of these collaborations are there. And in India, there are many institutions are there where these collaborations exist. So one can join it as a PhD student in any of them or as a faculty, and then one can be part of it.
Yes, definitely, sir. So my next question will be to Professor Barman. Sir, am I audible to you?
Yes, you are audible.
Okay. Very good afternoon, sir, and thank you for joining. So the first question will be more or less the same, that how has your journey from a B.sc to a PhD in physics, which has shaped your career in this academia and research, sir?
Yeah, thank you very much. First of all, I'd like to thank you and the organizers for inviting me over this interesting panel discussion. It has been really interesting to hear all the other participants. So regarding my journey, as you probably has flashed already, that I have done my B.sc and M.sc from University of Calcutta. And as you know that in University of Calcutta, it's a very extensive program in physics, but it's primarily theoretical. So we have very little exposure to the experimental science during our B.sc and M.sc, barring the the lab courses. But I always had interest in experimental science, so I chose my PhD in experimental science, and there actually my journey begins from there, because to get to know the techniques, the very intricate techniques of the experiments. So, for example, my PhD was to study the transport and magnetic and optical properties of various materials, and for that we had to do work in extremely low temperature, in liquid helium temperature, at very high superconducting magnetic fields, very high magnetic field using superconducting magnets, and so on. So we get to know all these things, how liquid heliums are produced, and they are used, and then how you handle them, and and then how you really measure the the transport in those systems at very low temperature and high magnetic field, and how to interpret those data. And there I started to get huge interest in physics. And then slowly I moved into other, like during my postdoc. First I worked in Technion in Israel, where I was working on superconducting and magnetic devices, and also hybrid devices, where I was able to make nano devices and micro devices using lithography. So this is one of the techniques which has been regularly used these days in the semiconducting industries, and other magnetic industries and other industries, but has not been available those days in India. But I got to learn those techniques when I was doing my postdoc. There's lithography to make devices. And then I moved on to UK in University of Exeter and then University of Leeds. So there I actually got to work on using optical techniques, using femtosecond lasers to study very fast dynamics, which can occur in 10 to the power minus 15 seconds of materials like electrons, spins, lattice, and other degrees of freedom of material. And those were fundamental to various devices, because our magnetic read write technology, if we have a magnetic read write technology in our hard disk, our computers, and our mobile phones, and everywhere these days. But the technology is primarily working in microsecond time scale. And in order to move it to faster, so we can store a lot of data, but to read and write those data faster is a challenge. Okay, so that is why you see that we are taking, it takes a lot of time to read the data and to write the data. So in order to move it faster, one has to go into other kind of physics like precessional dynamics and other femtosecond dynamics of magnetization and electrons and spins. And I started to learn that and study those in UK. And we developed something called time-resolved magneto-optical Carr effect microscope for the first time. And we were able to study very small nanomagnets and their dynamics and so on. And then I moved to University of Leeds, and there I started to not only to study but to control the dynamics. So we used optical pump probe techniques as well as optical pulse shaping. So this is a very interesting technique where you can take a laser pulse and you Fourier transform it by using a grating, and then you can actually use a special light modulator, and you can change the individual amplitude and phase of the different parts of the laser, and then you can Fourier transform it back, and then actually you can get a shaped a laser which has a particular shape in the time domain. So by which you can actually control various things like different dynamics and even molecular reaction. So we did those studies on different kinds of systems, and then I moved to US and I moved to University of California in Santa Cruz, and there I also worked on optical techniques, very high uh, pulsed laser technique to use to study this ultra fast spin dynamics in different kinds of nanomagnets and different materials. And beyond that, I actually joined in University of South Carolina as an assistant professor. But then I was also having some interest to come back to India. So I was, having an offer from IIT Delhi. So after, about a year in University of South Carolina, I came back to IIT Delhi, and I joined as an assistant professor there. And I started my own group, started the teaching and research program there. And after 3 years, I actually came back to Kolkata, because I was actually invited to join the SN National Center for Basic Sciences by then the director, Professor A.K. Raichoudhury was the director there. And I joined there as an associate professor, and there in 2009, and then I formed my group. And today we have like a group of about 20 people who are working in different arenas of spintronics, quantum materials, quantum computing, and different kinds of technology, science and technology. About 22 students have already completed their PhD from my group, and many postdocs and master students, and they are now established all over the world, both in academia and industry. And yeah, so that is all about my journey so far.
Thank you so much, sir. This is really wonderful. So, in this regard, I want to ask you that what opportunities do you see for students from the physics background in the field of academic research, and especially in your domain? And how can they prepare for a successful career I'm not saying like you, but at least a successful career in this area?
These days the opportunities are huge. During our time, we only have the research career or teaching career, but these days one can also go to industry even after their masters or after PhD or postdoc. And also they can go to different other career like sort of scientific communication, content developing, and various other careers. And I would say that all these careers are very rewarding. But coming back to the academic or research career, I mean, people can definitely follow the path of clearing some national level exams and then sort of get into different institutes or universities uh, by following the protocols. And these days, a lot of people are also going to Europe and United States, Japan, Australia, and various other countries. And this is quite straightforward. You need to do a very good, sort of internship, summer internship, or other kind of internship in a good institute, and get some good recommendations, and sort of and form a good sort of CV with some solid background in some experimental or theoretical science, and then apply in those kind of domains, so that you can establish that you are. I mean, instead of just applying randomly with a random sort of CV, you from your B.sc and M.sc you do good internship, you form a good CV, and then you apply to those domains particularly, and have good recommendation letters, and you will very easily be absorbed in those institutes or institutes or universities abroad. In India, of course the protocols are slightly different. You have to go through the interview process. But once you are there, then you have to really prove your mettle, because you have to show that you can do research independently, and that independence has to come from your own interest and your own skills that you will have to develop from time to time.
Thank you, sir. I want to ask Professor Shukla that since you are heading the quantum computational section as well, what is the future of quantum computing, especially in our country, when government of India approved, if I am not wrong, 6,000 crore of boost up quantum technology? Am I right? So what is the scope? What is the future?
So I would, I think that the government has done his role, and it's a big step and I think it's a very good vision from the government that they have approved this budget of huge budget for national. This is called National Quantum Mission, and this has been already taken off from I think January or February. This Department of Science and Technology, they invited a lot of proposals for establishing the quantum labs and all, and it seems there have been hundreds of proposals from IITs, from universities. They have applied for this funding. Of course, the fund 6,000 crore looks huge, but India is a very big country, and there are many institutes, and fortunately now there are many IITs and many even private universities, and lot of talent has been absorbed there, and people want to work there. So I think that in next 3 to 4 years, whatever these funds which is it is still not distributed, but in few months time you will see that this fund will flow. Already there is a roadmap has been there. Means it's already in the process of evaluating the proposals, etc. So definitely I see very bright future. I think in next 4 to 5 years, there will be I'm hoping that there will be very good development in this quantum physics. So it is basically they are divided into four hubs. One is quantum computing, one is quantum communication, one is quantum sensor, and one is quantum materials. So in all these four areas, we are hoping, and I'm sure in 4 to 5 years from now, India will be in a very good shape because we have talent, we have people who want to work, and they have expertise. Expertise is also there. In fact, expertise. Uh, 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 People have worked as a postdoc and as a PhD or somewhere in the abroad, and these people are faculties now. They will develop its facilities here. So I think a very good future for this and a very good initiative from the government. At least this much fund will go into the research, and this will be mostly used constructively, building your facilities, labs, measurement, and lot of knowledge generation.
Thank you, sir. Yeah, that is really hopeful for us, actually. There is one question for you, particularly from one of the students. He wanted to know from where and what is the scope in India as a high energy accelerator physicist after PhD?
Yes. So if you see the particle accelerator, uh, mostly it is done by Department of Atomic Energy. Basically, the department from where I come. So you can see there are accelerator developed in Bhabha Atomic Research Center. Even in Calcutta, you might have been knowing Variable Energy Cyclotron Center. There also there is a particle accelerator cyclotron. They have now moved to superconducting cyclotron, which is very recently inaugurated, and it's working. And also in New Delhi. Unfortunately, we do not have a very high energy accelerator in India. So basically, we are going up to 200, 300 million electron volts of energy in India. So, for example, the energy ranges where I have worked in GeV or in TeV range, there we have actually collaborated outside, and that's where making very high energy accelerator, big accelerator needs lot of funds, lot of space, and lot of manpower. And as you know that there are international collaborations in these areas. So the big accelerator at one place, and many countries are participating. In fact, if you see this this CERN complex, this actually passes from two countries, Switzerland and France. So even an accelerator which is 27 kilometer of circumference, it is moving through two countries. So in India, of course, that is one of our emphasis in BRZ. One is the reactor and one is accelerator. So accelerator is now is one of the it is emphasized as one of the most important program in our department. So I am hopeful that in future we will also be increasing up in the energy of the accelerator. So that's
Thank you, sir. I hope, Chirag, you have got your answer. So I will like to ask Professor Barman, sir, one of the students, Shaulina from DAV School, IIT Kharagpur, has asked, which part of the physics is the main reason of development of technology in India and affordable for common people, which is important, I think. for all of us?
Yeah, there are quite a few actually, but what I have seen recently is the biomedical physics, or biomedical instrumentations has become a core research areas in India recently, with many of the spectroscopic and optical techniques and also electrical techniques have been used for detecting different kinds of diseases. For example, starting from diabetes, and various other kidney disease, Helicobacter pylori, and various other, based diseases. And so disease detection, early detection of disease and non-invasive way of detecting diseases have become a very important part. And this way, some technology have been developed and also been transferred to different industries, and Indian industries are coming up for getting those transferred. The other part that I have been also involved, particularly, is sort of the microwave technologies, like very high frequency components and devices, which are very important for different kind of sort of techniques, like mobile phone, and to be even radar, and various other kinds of technologies. So yeah, so there are many aspects of it, even particle detectors and various other astrophysics related telescopes and various other things are coming up. In this way, I would also like to mention that very few industries have really come up recently. One is, for example, Reliance New Energy, where one of my students has recently joined, and they have started the photovoltaics based technologies, and they are actually making photovoltaic cells, which were not available in India, because people used to buy the cells from abroad and then make the panels. And now Reliance is making the cells also, trying to make the cells also, and they're getting their people trained, and using indigenous technologies to develop the cells. And sort of other, like Applied Materials, General Electric in Bangalore, Applied Materials in New Delhi, they are all interested in various developing new materials and application of those in different, from starting from health sector to computing, to aerospace and different kinds of sectors. So a lot of things are happening these days. And here, even condensed matter physics, engineering physics, optics, spectroscopy, even nuclear physics, astrophysics, all these different parts of physics are involved. So I would say that you take any topic of physics and study it well, and try to do something fundamental in those, and you will succeed in developing technologies.
Sorry, I was mute myself. So, sir, another question from student Preeti De. She is asking that she wants to pursue the career and she has an interest on quantum physics. So, what are the steps and what will be the future trends? So, one already Professor Shukla has said the quantum computing. Is there any other thing actually?
Actually, any advanced topics in physics is an application of quantum mechanics. Even
Yes.
solid state physics and nuclear physics, anything that you study in future
Yes.
will
Yeah.
be an application of quantum mechanics. Of course, if somebody is interested to develop quantum technologies, like quantum computing, quantum communication, quantum sensing and metrology, quantum materials and devices, and this National Quantum Mission is one of the sort of roadmap, or one of the ways to move forward. And it's an 8-year project, where Professor Shukla has already mentioned that more than hundreds of proposals have been submitted.
Mhm.
And the idea is to sort of develop a 1,000-qubit computer, quantum computer, in 8 years. as you may know, that IBM has recently launched or announced a 1000-qubit computer, quantum computer. But in India, the research has not progressed to that level, although some of our colleagues are doing several qubits of quantum computers. So the idea is to catch up and reach there, and for that you have different pillars, and those will support in achieving those. And in that way, quantum sensing and metrology, quantum materials, and quantum communication will provide the support to finally to reach those things. And of course, you can also study various other fields of physics where quantum mechanics will be useful. So so idea is you study it well and understand it well, and then the applications will
Application will come. Yes,
come in its
definitely.
own way.
Yes, yeah, definitely, sir. So my next question to Professor Shukla, another question from student actually. Uh, is there any chance to get a job in B.sc for M.sc physics students? And then what would be the role of that person there? If you just say a few things actually.
Yes, BRC recruits every year. This advertisement comes somewhere in December and January, so one can catch up for it, and you can apply for it as an MSc final year student. You can apply, and there is an entrance test. I think Calcutta may also be is also a center for the entrance test.
Yes.
And if you clear that entrance test, then one is you can be you are called for interview, and this interview happens mostly in Mumbai in VRC. There are also, other than entrance test, gate score, and there are I think there is one exam which is called GEST, GEST. On the basis of that score also you can apply for the on this advertisement, and you can be called for an interview. So then you have to face an interview which is mostly based on physics knowledge during your MSc time. So if you have really developed very good concepts during your your MSc, then you can you can very well pass that interview, and then after you pass, you go for 1 year training, and then uh, suppose suppose there are 20 MSc people are selected, then you will find that there are 20 vacancies are generated in BRC, in VCC, in RRCAT Indore. I think there are 4-5 institutes of our department, and so all 20 vacancies will be on different fields. From there, you can choose based on your ranking. So suppose your rank is first, you have 20 choice. You can choose any one of the 20. And if your rank is 20, then whatever is the last choice, basically, but even those that choice is not bad. So it's not so even if a person gets last rank out of 20, that also is not a bad thing. So this is one entry. Actually, this is the main entry for scientists through this scheme. Other ways one can apply for junior research fellow. So that is also advertised every year. So one can, so that we get a degree through Homi Bhabha National Institute. So recently we have selected 40 people for physics. Again, they go for 1 year course work, I think 6 months course work. Then they can choose a stream in many divisions wherever you want to work. So that's where So this is second. One can also do summer internship, summer project. One can do that if you see at BRC website student corner, you will get that information. You can apply through our HRDD. Suppose you want to do a 2 months project or 3 months project, summer project. For example, suppose you want to work with me as a project trainee, you can apply to HRDD giving my name that I'm interested to work with this person in this division, and then they forward it to me. So it happens like this. So those applications are scrutinized, and some of them get opportunity to work as a project trainee. Only thing here is BRC does not provide a financial fellowship for the internship. So this is a project which has to be funded by the student. Only thing is that they get a good training here and good work.
Yes,
So
yes. Thank you so much, sir. Actually, there are lots of questions, more than 100 questions in the chat box, but due to shortage of time, we can't take all of them. So this is a request to both of you, to Shukla sir and Barman sir. If we send the question to you personally, can you please give some time to answer so that we can communicate to the students directly?
yes, definitely we'll be happy to answer all the questions.
Okay, thank you so much, sir. Thank you so much for giving your time for this panel discussion. And this is really a never-ending discussion. I love to hear from both of you actually. And thank you once again for joining. Thank you, sir.
Thank
Over
you
to
so much.
Dr. Mukherjee.
Okay.
Yeah,
Thanks for to invite me for this these sessions, and in fact I find it very useful, and for the students especially, and I have I think first time joined such such
Thank you, sir.
session.
Thank you.
No, not first time. I think this was second, but earlier I had done offline, not online.
Yeah,
So
this time
this was
also we thought it will be offline, but then
okay.
we think it's better to go for online.
Okay.
Okay.
So thanks and all the best to
Thank you,
you
sir.
and all the
I will keep
students.
in touch with you,
Okay.
sir.
Okay. Thanks.
Thank you, Barman, sir.
Thank you.
Thank you once
Thank you.
again.
Bye bye.
Thank you. Bye-bye.
Bye.
Bye-bye. Over to you, Dr. Mukherjee.
yeah. Thank you, Professor Sharma and Professor Shukla and Professor Barman, and thank you, Dr. Bhattacharya, for conducting this. So, let us welcome our next set of experts. So we have Dr. Abhishek Atreya, uh, Dr. Miss Daisymol, sorry for the interruption, and Dr. Aditya Mandava. So now, before we go into the discussions, let me briefly tell something about our experts. So at this point, I would like to also mention that Dr. Sudipta Samanta was supposed to join us today, uh, but he got his COVID infection on Saturday. So he couldn't join us, but he will be. So if you have any questions on AIML and biophysics and related research, you can ask these questions in the chat box in the Facebook page or in other way, and he will be happy to answer those questions once he recovered. And we'll be having a separate online session with him as well. Okay. So with this, let us welcome our next set of experts. So we have Dr. Abhishek Atreya, who is currently Assistant Vice President at Barclays. So Abhishek graduated from Institute of Physics and his area was quark-gluon plasma and high energy physics. And then he moved on to investment banking and quantitative research. So welcome, Dr. Atreya. So we also have Miss Daisymol Manjaly. So she is currently at Puma Energy as a senior payroll analyst. So her expertise in global mobility, tax management, HR operations, project and account management, and her previous employment was with EY Tax and Deloitte. Okay, and then our next expert is Dr. Aditya Mandava. So he is currently the application engineer and radiological safety officer, and also the Indian ambassador of WINS Academy Vienna. So he did his master's degree in nuclear physics, and he's expert in gamma spectroscopy, alpha spectroscopy, and radiation monitoring. And he's certified as radiological safety officer by BARC India, and also he holds specialized professional certification in nuclear security from the WINS Academy Vienna. He also his membership includes Indian Society for Radiation Physics, Indian Association of Nuclear Chemists and Allied Scientists, Indian Youth Nuclear Society. So let us welcome our next set of experts. So let me stop sharing this now and go back to the normal mode. Yes. So Dr. Atreya, are you there?
Hello, hi Tamara.
Hi, Abhishek. Yeah.
So yes. So
Yes.
can you start with the next speaker? I think my father is on the door. I'll just open the door for
Yeah,
him.
yeah, sure. So, Purva, maybe you can start with
Yes, I
yeah,
can start with hi Desi, how are you?
Hi, Komal. Yeah, good.
Good. So, can you please tell me a bit that how has your background in physics, you are from a physics background, have been beneficial in the energy sector? And what unique perspective does it bring to your role at Puma Energy? Daisy, are you there? Hello?
I'm so sorry. I think something went wrong.
Okay. Hello?
Can you hear me now?
Yes, now. Yes, please.
Yeah. Yeah. Sorry, I think I missed something. Yeah. But yeah, thanks for inviting me. And yeah, I felt let me just talk something, beyond what you asked. So I think it's good, but I felt like I'm back to some physics class, just telling the panelists for, the, so it was good, for me, hearing a lot of physics terminologies and also thanks for inviting me to this event. Coming to the so yeah, so am I audible?
Purva, I guess there might be
Daisy,
some
yes,
network problem.
there is
So
some internet problem. So can you
maybe you
please
can start with
rejoin?
Aditya.
Yeah. Can you please rejoin, Daisy?
Okay, just
In the meantime,
I'll
I
try.
can.
I'll try.
Yeah.
Sure.
So, Aditya, are you there? Am I audible to you, Aditya?
Yeah, hi, Dr. Prabha. Am I audible?
Hi. Yeah.
Am I audible?
So, yes, absolutely. Perfect.
Okay.
So, you have a very interesting roadmap, actually. What motivated you to transition from a traditional physics career? You were a M.sc physics to the role in radiation safety and international advocacy. How?
Yeah, firstly, let me thank you for the organizers for inviting me to this event. And coming to the roadmap or something, so I did my master's in nuclear physics from Andhra University, and where my professor has taught me something very in a different kind of manner where physics is not to be taught. Matlab, where physics is usually taught. So they have taught me something good manner where I can learn new things and new topics and in a different kind of examples or states and everything. So when I was there, I have gained knowledge and interest in gamma spectroscopy. So after that, I have joined a private organization and I worked as an analyst for gamma spectroscopy. and there I got more interest in those kind of topics. And during the job there, I was used to have a certification in the radiation safety, so which is mandatory by the BRC or AERB. So I went for this RSO certification there, and from then I left the job and I have joined Advanced Tech Controls as an application engineer. And here my company has supported me a lot in the same field to continue as a nuclear physicist and radiation safety officer. And here, we well as an RSO, we have to follow certain rules and regulations set by AERB as well as some set by IAEA. So when my interest was on IAEA set of rules and guidelines, I came across the WINS Academy, and my interest has shifted to go to WINS Academy for gaining some expertise in nuclear security as well as nuclear safety. So I did some courses in nuclear security from WINS Academy, and then I got an opportunity to join as WINS as an ambassador there. So I joined WINS as an ambassador, and I'm promoting nuclear safety as well as nuclear safety security in India.
Wonderful. Really a different pathway actually to continue. So, Daisy, are you being able to hear me? Not now, not yet. There is a network issue. So maybe we can go to with Dr. Abhishek, Dr. Mukherjee.
Yeah, Abhishek, are you there?
Yes, Dada. I'm
Okay. Yeah. So let us start with your journey. So tell us about it. So it's a very interesting one.
You know, of course. Thank you.
Yeah.
It's see, I mean, my father is an English teacher. I start from him because a lot of things, when I think about it, it comes from him. So he was the person who was knocking on the door when I excused myself. So he used to recite a couple of poems to me, and one of the poems that he said was "Road Not Taken" by Robert Frost, and it actually ended up the same for me. I mean, my goal was to be a teacher in the same school I was studying because I liked my teachers. Some of them were really nice. Maybe it was a blessing. So not everyone likes their teachers. So, but then it grew. I grew out of this being a teacher in the same school. When I did my B.sc. I was not sure what I'll do. I was exploring. I liked physics. I liked mathematics. So natural thing was that I apply for masters, but then there are people who actually tell you, "Arey, kya karega masters karke?" And it's useless. I mean, what will he do? It's just a postgraduate, will no value. But thankfully, I got decent rank in DU entrance exam. So I went there for my masters, where I got some real good teachers, and I understood what it means. Getting exposed to a good environment is very, very crucial for your growth. And that's what I would say my journey started from there. And PhD became the de facto thing to go, just as I was in my final semester. And that's when I came to IOP Bhubaneswar after clearing chess. So when Prashant was talking about all these jest, gate, and everything, but even DRDO used to have these entrants. I appeared for each and every one of them. I was in the interview of each of every one of these institutes, different places. But I was happy and lucky, I would say, to get a chance at IOP. I got chance at others, but I chose to be at IOP. And it people say you learn physics in PhD. I say no. I think I grew up as a person. Tamal, he knows me for a long time now. So he saw me when I was a young PhD. Okay, that person is very different from what you see today. If you knew me then, and if you know me now, a lot of things has changed because of the process itself called PhD, which we talk about. It's very different. The experience that you live, where you critically think, analyze not only the work that you do, maybe if you are in a good company, you will also critically think and analyze your role in society and various other things. So this becomes a very important part of your growth. And I would say it becomes a part of your life till you are on this planet. So that remained. And that curiosity, exploration attitude was there. But natural thing was that, okay, I'll be now a professor. Just like initially I was like, I'll be a teacher, I'll be now a professor. And when I decided to be a professor, I thought that, okay, let's do a postdoc. And then let's do another postdoc. And let's do another postdoc. So, I mean, I know you all might be feeling this or might have gone through the same path, but I was on the same trajectory until something not so very nice happened, which is related to the funding in India. Okay, but let's not go there. Luckily, at that particular point, one of my okay, I'll just mention this. I had to write to PMO to get my funding released. I was without any funding for 11 months, and my mentor was paying me every month out of his pocket. Kamal Das, a PhD guy, he was my mentor in my postdoc. So it was not a very good condition. You are 30 plus, you have a kid, so you really don't want all that. And when I wrote to PMO, I got my salary within 15 days, 20 days. But one of my friend saw this and asked if I'm interested in moving out. Those were the time when I used to be on Facebook. So he connected me on Facebook and said, hey, man, you want to leave all this and move to, move to a trading firm. I was like, sorry, excuse me, what? No. I think you got the wrong Abhishek. So he said, no, I'm talking to the right person. He was my Delhi University batchmate. And then I thought, okay, let's give it a try. And you won't believe, I prepared for it like an exam. They gave me some books to read because I clearly asked, what do you want me to do? It's exactly the same question like a PhD or MSc students or B.sc students that I'm seeing asking here. What do you ask me to do in a trading firm? I have no clue about which stocks to buy, which stocks to sell, or what. What will I do? So they gave me a couple of texts to read. I looked at them, I tried to understand them. And they said, okay, if you find them useful, let's talk after a month. And that talk after a month was my interview. And I cleared that. But that love for physics keeps coming back. It's like your girlfriend who you don't want to break up with. And so I said, no, they said, okay, when can you join? I said, no, I'm not interested in joining. I am getting a chance to visit Austria, Germany, and Finland this winter. And I'll try to see my chances there. And I went there. It was in June 2018 that I rejected the offer. And I went in November to Europe. I was there for a couple of months, presented a few things. And the thing was that coming fall, I'll be applying on those places. I gave presentations in Munich, Finland, Austria, in the conferences, other places. It seemed to be falling in place. Okay, good. And then when I come back, my fellowship has still not come. 1 year has passed, second year has started, so it stopped. And that's when I decided, I think I should cut this cycle of living like this and should also focus on my own personal health, financial health, mental health, because it has lots of side effects. maybe it's not as rosy picture, which you have heard from previous uh, speakers, but this is actually the story, as Tamalda was saying, very interesting one, the path not taken. This is actually how the story goes with me. And I decided to put my papers. And I asked these guys, I still remember I was in ISC Bangalore at that time, conference. We were discussing, and then I just decided to call my friend, say, is the offer still on table? And he said, are you interested? I said, well, I think I can give it a try. And that's when, in the conference, while everyone else was talking about collaboration, I was talking about salary negotiations with HR. So that's when in June 2019, a year after my interview, I joined. And my first job was at Daulat Capital, Mumbai, which is a high frequency trading firm. And my job there was to just study the market data, the way trade comes, an order comes, someone agrees, yes, I will buy this many I will buy, this many I will sell, whatever. I have to look at that pattern, make sense of it, and predict in the next instant what's going to happen. Is it going to be a buy or is it going to be a sell? So whether the price will move up, because if the price goes up, mostly people book the profit and sell. If the price goes down, people try to go and buy. So my goal was to predict as much as, as effectively as I can, the price movements in the market. And I was modeling those. And if you will believe me, in my team, there were 7 people who were PhDs from eminent research institutes in India. I was from IUP. I had my colleague who was from IMSC, Chennai. Another colleague from, I think, Kolkata, ISER Kolkata. From Physical Research Laboratory, Ahmedabad. You name any research institute in India. DAE, BARC, whatever place comes to your mind, these people were from those places. IITians were there who were working with us on signal processing, on coding aspects of it. So that's when I realized, okay, all that I did in these 10, 15 years as a PhD, as a postdoc, it's not that I can only teach someone or I can publish papers. I can even earn money for myself and for someone else, maybe. Because someone else is trading based on what I'm telling them. You go and buy this stuff. Now, I want to just correct one thing here. That doesn't mean that I'm an investment banker. I'm just an analyst. Okay. Because so Tamalda, as he said, investment banker scares me. That's not what I do. I don't go and talk to clients. I've never done that. I can never do that. I can never convince them to buy or sell. I don't think I have that capacity to pitch things very effectively. So yeah, that was my first job. But again, it didn't last. I started realizing where my academic orientations were getting in conflict with the way things need to be done and the way I'm doing things. And that's when I thought maybe it's not a good place. It's a good place. It was a good place to work. Some of my friends from then are still working there. So it was not for me. I could not trade. You give me 5,000 rupees and say, okay, put this in the market and buy and sell. My hands will start shaking. I can't do that. That's not someone whom they would like to have on the team. Then I decided to make a switch to investment banks. So then my next job was for Deutsche Bank. And I came to the something what you call as the risk profile. So currently I'm in the risk profile. Like everything in the market, there is a risk associated uh, with whatever you do in finance. So you buy, there is a risk associated with it. You sell, there is a risk associated with it. And to be honest, a trader does not care. Mostly they are very intuitive people. They understand the dynamics of the market reasonably well. So they'll buy and sell things very effectively. And most of the time they make healthy profits at the cost of people like me who go and start trading, who have no clue, and they just trade on hunch. So we lose money and they make money. However, sometimes if things go wrong, because you are making a lot of money, so you're betting a big, your bets are getting bigger and bigger. If suddenly there is something, one off instance that goes against you, there is a very steep downfall and you can make huge losses, not for the bank itself, but for the clients of the bank. So it's not your money which is at risk, it is your client's money also at risk. And this is what happened in 2009, financial day, 9 financial crisis, where Lehman Brothers being the biggest name in the financial industry, and there were many others that completely failed. So earlier it was supposed to, the view was that banks won't fail, but they did fail because they did not see the risk uh, that was coming their way. They just did not analyze it. They were just too reliant on the models they're working with. They're just too reliant on the intuitions people have of the market. And that's when Federal Reserve and all the other, like RBI today in India doing this, with Paytm they did, and with Kotak they did, they started intervening. And they started putting regulations that you need to do a basic amount of checks before you do something with someone's money. And that's where my job started creating. So when I started my PhD, you can say around that time, these jobs started getting created, which is the risk jobs. And I worked there in Deutsche Bank for 2 years. Now I work in Barclays. Again, a similar, same risk profile. But I mean, just like even in condensed matter physics. So finance is like physics. Risk, you can say, is like one sub branch, maybe cosmology or QGB or condensed matter. You have within the risk also various bifurcations, just like as you specialize more in it. So my specialization now is different. Essentially, the broad story is same. That's my journey in not so short, small words.
Thank you, Abhishek. So I am aware of there are many students who are following you closely. So there might be few questions from the audiences as well. So
Please,
let
I mean,
us hear out.
one-to-one,
Yeah,
if it is
yeah,
possible, I love that.
yeah. I'll ask them to unmute themselves and ask you. But before them, let's hear it out from the other expert as well. So Purva, can you please ask Daisymol to share her
Yes.
journey?
Yeah, Daisy, am I
Hi, hi.
audible to you?
Yes, yes. Am I
Yes.
audible to you?
Yeah, so can you please share your journey from a physics background to your role at Puma Energy?
Yeah, yeah. So, my journey is something like, yeah. So I was very passionate about physics. I started my bachelor's. I think somewhere in the mid, like, many of maybe I heard, all the discussions were, maybe, some of us some of feel like, is it really interesting, or what are the future opportunities, and should we go for research, and what is the for us in the future, etc. So but I always follow the basics. So I did, my studies well, and then I continued, my master's because I thought, it's not, it's very, I felt it's my personal opinion, but it's very early to decide whether I should pursue physics or not when I was doing my bachelor's. So I wanted to, even deep dive physics a bit more to, fully realize what I exactly wanted to do. And also the subject was very interesting. Like Abhishek told that, a lost girlfriend kind of feeling you always have for physics even now. So, whenever somebody, if there is the word buzzing around you, you always feel like, oh, I lost it kind of feeling. But still, I heard Abhishek even mentioning that physics is like finance and, all those analogies. So I completely agree with that. So right now, yeah, so after my master's, so probably accidentally I got my campus placement. Probably I would say that way. And then I was validating, should I, take that opportunity and, or should I, continue for my research, tries and all. Then I thought, I decided, okay, probably I'll work maybe 1 or 2 years, and then I'll save some money and maybe I'll go for research and then I joined EY. Back then it was a campus placement, and I was part of the tax team in EY. So it was more like a tax support team because again I have a physics background and the tax experts majorly probably commerce graduates and etc. So I was initially placed in the tax supporting team, and then I think I spent 5.5 years there. And every year I used to think that probably next year I may quit and try again back to physics and all. But eventually, somewhere I found that synergy with what I'm doing every day, and I could relate a lot of probably the logic or the problem solving, and I think physics is more than a science. It's more like a philosophy where it guides you to maybe the skill set you earn throughout your physics education is helping you to navigate your everyday challenges and struggles. So I continue doing what I was doing, and then I get into the core tax team, where I was part of a tax crossover training batch in EY. So it was more like a few people who did not have any commerce background or tax background or academically not from taxes. We were chosen to go through the extensive training program for US taxes, and I was one of them who got the opportunity. So I was like, okay, why not? Let's try. Because every day after six, experimental mindset leads us to, doing things like that. So I did that. And I'm a person who are more like very intuitive, and I have that spontaneity as well. So, I heard, my inner voice probably, and I'm sure all most of our, the folks here around are very intuitive. That's, I think, one of the key trait of most of the physics enthusiasts is what I have even observed. And then, yeah, so on the way, after that, again, I got an opportunity from Deloitte that was for client account management. So it's more like managing your clients and engaging them with certain activities and, tracking how business is doing with them, etc. So I was briefly involved in that team for a few, I think it was less than a year. And due to some personal commitments, I had to quit it. And, I was actually relocating to a new city. And that's when I got this opportunity from Puma, which is based, I mean, my office is based in Mumbai. It's a Swiss based oil and gas company where I am currently working in the HR function, handling the payroll. So it's again, a bit of finance and HR admin activities. So coming back to your question, Pubadi, so I would say, maybe studying physics or, being from physics background, I think I now know, probably what how to handle people, how they are, the psychology, probably I would say, you can tackle those things and talk to your people and understand what is happening there. And there are times you can convince people and actually help them to have a better maybe employment life, I would say, because this is more like that. And Then comes to payroll, it's the, kind of, probably a subdivision of finance. So you are good with numbers when you study your physics and, a lot of mathematical physics, all your 5 years of, calculations and all those things, reconciliations. I think it's every day, it's more like, doing my physics experiments back in the college. So, I just get into I do certain, calculations. There might be some errors. I go back and, check what is happening, and then, be fixing it. So that's how it is, helping me, my everyday life. So I'm always, very proud that, I studied physics for 5 years. Probably that made me very strong to handle my, everyday challenges. And when it comes to energy sector, so these people, I mean, since I'm in the human resource department, and the employees are majorly placed in the downstream oil and gas business, and whenever they say something technical, you can actually understand, because it covers everything. So physics is very fundamental discipline, for you to understand what the other person speaks, so you can be one of them when you talk to them. So that helps me a lot. So that's, I think, yeah, that's all about my journey, and probably how physics is helping me every day.
Yeah, really great to hear this, both from Abhishek and Daisy, actually. More or less the same kind of mindset, actually. Really great. So what to you, Dr. Mukherjee?
Yeah. So there is a question for Abhishek, but before going to that questions, I would like to ask, because there is some questions we collected from the registration form. So this question basically asking you that how did you make this? So suppose, for example, someone wants to make this transitions from physics, B.sc, M.sc physics, from B.sc, M.sc physics to the uh, financial sector. So what are the skills you require, or what are the extra things you need to know? I mean, because under national educational policies, this students get to study, apart from physics, some other subjects as part of their minor subjects, as part of their multidisciplinary course, ability enhancement course, skill enhancement course. So what do you suggest? What subjects they should take?
Thanks, Dada.
Yeah.
This is a very, very, very pertinent thing. I have lots of friends who have moved, and I do have discussions with them about what they know and what they can know. One of the things which I remember from Momita ma'am's slide is your soft skills. It's the most important thing. I don't think they will doubt your capabilities if you're a PhD or a master's in physics or mathematics. Okay, they'll not doubt your analytical capabilities. They'll not doubt your uh, thinking capabilities. That prowess you already have. You already have proven yourself that you're good enough to do this. Now, why do you need those soft skills? Is because unlike research, you're not solving it in your head and pen and paper. There you are like a teacher who is actually explaining it to students. A good researcher is not always a good teacher. He has to break it down in simple terms to explain it to someone who is in front of you, who might not know that well. Technicality is very well. And that's where soft skill come. I mean, very, very handy. You will be talking to people who are from MBA background. You will be talking to people. I mean, uh, we have one of our colleagues here, one of our panelists here who is in HR. But I talk to people who are in HR who are coming from completely different background. She's physicist. I can still communicate with her in the way I talk to you, Amalda. But you can't do that. And when you are talking to traders, when I was in the dollar capital and I was explaining it to the traders, I realized I cannot explain them in terms of the mathematics. I have to break the mathematics and use plain English. And that's where your soft skill come in play. And they become very useful. How good you are in explaining it. I think this is also a skill you will learn during your PhD, definitely in your PhD, because one of the crucial aspect of a good PhD training is to understand things in simpler way, to break it down. Like, can you explain it to your grandma kind of thing? But even in your masters, you should strive. So for example, electrodynamics by Griffiths is much more popular than J.D. Jackson, simply because it does the job of explaining it much more nicely. Okay? The same soft skill you need. There's no way avoiding it. You have linear algebra, which you can use in AI ML, basics of differential, I mean, sorry, not differential geometry, PDEs. Okay, you know how to solve partial differential equations. You know how to solve linear algebra matrices and all that. You know how to do the upper diagonal or the lower diagonal triangulation of us n by n matrix and all that. You know how to calculate the eigenvectors, eigenvalues. All these basic techniques are used in the standard AIML processes. These are the steps you will learn. They will always teach you when you go for these courses. What they will not teach you is how do you explain it or convey the results, outcome plots explain. So no way you can avoid this. It's a must have.
Okay, thank you very much. So there is another question. Someone is doing PhDs and also a little bit of investing. So he's asking how can one optimize to get more from PhD as well as trading.
PhD is the time when you can do anything you want in the world, along with your research. After that, you'll never get a time to do that. Okay. Ask any of your professors. So if you're doing a PhD, do as much as you can on your research, but all the other time you can do whatever you want. I'm not a trader. I was the guy who was working for a trading firm and working on models. So you can learn about that, the modeling aspect of it, if you want to do. Or if you don't want to do, you can go to the Zerodha's website and they have a, I think Zerodha Varsity has a few chapters, modules on uh, basic trading. They have a varsity university kind of thing. They used to have, at least when I was checking it in the trading firm. And they explain some basic strategies. How do you deal with that? You can look up and explore, I would say.
Yeah, thank you, Abhishek. So, students, if you have any questions to our panelists, please feel free to write them out in the chat box. So, in the meanwhile, I would like to request Dr. Bhattacharya to ask some other questions to our other panelists as well.
Yeah, maybe to Aditya. So, what advice will you give to students about the networking, internship, or other ways to enhance their career prospects? What is your opinion regarding this?
Yeah, regarding networking, internship, and all this, nowadays everyone is having internet connection on their hands, so they can approach international professors, they can reach out to conferences, they can seek advisors from the international directors or something who is in good research, doing research and different fields of physics. So they can join those firms as a trainee or as a summer intern or some other kind of training part or diploma part. They can gain some experience or some new techniques there, and they can get able to understand what is going and how physics is developing and what branches of physics can be able to give them good job opportunities or some other fields they can. So I think this is the best option to have good contacts all over the world. So through LinkedIn or through emails or through Facebook, something. they can reach many people all over the world and they can communicate with them.
Okay, so since you are from advanced, if I'm not very wrong, you are
Advanced Tech
from
Controls.
advanced tech controls. Yeah.
Yeah.
So is there any opportunity of doing the internship there?
Yes, we provide internship for the students, but those who are staying in Mumbai or near to Mumbai will be very helpful for them, because the stipend paid by company is not sufficient, so that the other people staying from other states cannot be able to sustain in Mumbai. So we do provide the internship, but those who are in Mumbai or near to Mumbai is much helpful for them.
Okay, that's good to know, actually. Daisy, can you please also, maybe actually this question is both for Abhishek and Daisy, that what job prospects and career opportunities are available for the students in physics, both within your specific field and the related industries?
Yeah, so what I believe is, like Abhishek told, we should have that, soft skills. And the other thing is, we always have a learning mindset. So I would say, watch out for the opportunities. Probably there are multiple platforms which, helps us to navigate through, and especially LinkedIn is one of it. And if you are really keen in getting a job, so probably Naukri is a good platform. So I even recommend that to my friends and family, that especially when there are young people, that just be on top of what is happening in the market, what is happening around the globe. And I'm sure the entire globe is right now watching out India, and the kind of the opportunities we are getting is immense. So it's us who has to navigate, and you should identify your own interest, and I should say, we should have that small term goals, where like I said, in my journey, every day, what I used to do whatever task was given to me, or whatever I can do beyond that. So if you're doing your 100% of everyday tasks, and then that helps you to navigate further, and whenever there's a good opportunity comes in, just be little bit experimentative mindset, and assess it, is it going to be good for you, is it helping, kind of fitting your aspirations, is it going to be an a good learning for you, or is it a completely new learning process for you? So I would say, I wouldn't say specifically do this, do that. Probably I would say try to understand what you exactly want to, and be on top of what is happening in the market, and in the country, and globally.
Okay, so same question to Abhishek, sir. If you want to just give some light.
Thanks, Dr. Bhattacharya. So one thing is, please don't call me sir.
Okay,
Abhishek,
no problem.
Abhishek works well for me. Now, options after masters are numerous. You have me as one example in finance, and that too after PhD. I have n number of examples from my DU batch who left after masters, who left physics after masters, moved to Infosys. Anjan sir was talking about applied materials. One of my friend moved to applied materials. She's now a director there in Mumbai. Okay. So applied materials is one of the firms which works with working with different kind of materials and films that are used in different industrial applications. So your physics knowledge is useful there. I have a friend, again, my M.sc friend, who moved to, she's now in Target, but so it's a completely different firm. I think it's a firm which was doing something novel. I don't exactly remember what it is. It's in Bangalore. A startup was there, and she's doing a very good work there. Pretty senior position now. Since it's been 20 years that I did my master's, so pretty senior position she's in now. I have my friends from Bose Institute who did their PhD in astrophysics. Someone was asking a lot of questions on astrophysics in the chat. So
Yes.
after doing her PhD, she did not wait for even defending it. She said, okay, fine. I have submitted my synopsis and I'll be writing now my thesis from the place where I'll be doing my job. She was very clear. She did PhD and she realized that's not where she wants to continue her life. She got the skills and grateful for it, but she moved to a firm which is using, which develops these lights, automotive lights. So BMWs, Audis, Mercs, they all have very unique light systems that is very focused on illuminating the path, how narrow the beam should be, how long the throw should be, how high it should be. You are using LEDs or you are using different projector headlamps, what kind of technologies you are using. So she is in the R&D of that particular firm in Pune. The firm is Czech-based. She goes to Czechoslovakia for her research work every year, and then she comes back. So, I mean, I am in finance, but I've given you 4 or 5 different examples where you can actually expand your food. And our speakers from places which I'm not counting on. So you can still count 10 at least places where you can expand your footing with the mastery that you have with M.sc or B.sc physics. So yeah, there is a lot. Sky is the limit, I would say. Data science, I mean, why not? Everything you study in quantum mechanics, which is the basic linear algebra, how you define it, it forms the backbone of all the AI ML things, which I never knew about. And then I said, in the trading firm, again, when you say the example, the things that what I learned from physics, and I was there, we were doing some predictive analysis because I was looking at the price movements and we were given the data. This is the input. This is how you want to predict. I said, man, this is so many variables and they have huge correlations between them. Can we not calculate the eigenvectors and using the eigenvectors which become independent of each other and we can try to predict something? And I didn't know till 2 years later that what I told them at that time, and this was knowledge coming from my quantum mechanics when we expand as the basis vectors, linear combination of the basis vector, any eigenstates. I was using that knowledge. And I realized exactly the same thing people use in what you call as principal component analysis. Principal component analysis is a very standard technique which is used to remove the correlations in your data. Correlations actually pollute your predictions. So essentially exactly the same thing. You have your X, Y, Z, you rotate it through 3 independent orthogonal directions and done. And I'm using technical language right now, which I cannot use when I'm talking to my finance colleagues, but I know that this audience will understand, so I'm using it. So because you have that expertise, all you need to do is just take a pause, think, and apply to a new system. Important point is when I said something about soft skill, I spent a lot of time telling you about soft skills. Try to understand the new system as well, where you are going to apply this. Okay, if I don't understand the system, I'll not be able to apply it properly. So please do that as well. You have n number of fields to go into. Sky is the limit. And I wish you all the best. I mean, that's all.
Thank you, actually. A few students have asked me if they can directly talk to you, actually, because they're really interested and they really follow you, actually. So what to Tamal sir?
Yes, I guess, I mean, we have to stop here for today because we are already 2.5 hours of session. So I think our speakers will be happy to answer
Yeah,
any
please.
questions
If
you might have. Yeah. So
if you
you can
wanna,
ask them.
sorry, Tamal. I'm just saying
Yeah,
that
yeah,
if
please.
anyone wants
Yeah,
to connect, they can connect me via LinkedIn.
yeah.
So I'm not on Facebook and WhatsApp or whatever you call, or Instagram, but you'll find me on LinkedIn. So there
So
we can
yeah.
definitely converse.
So please feel free to ask questions to any of our experts. You can ask them via us, or you can directly connect with them. So I think it was a nice session of from various backgrounds. People have viewed their opinions. So Purba, would you like to say something about this session, or would you have something in mind? Then please.
No, I will rather request Dr. De. Will you like to say something?
Well, it was a wonderful session. And most importantly, it was one of the most informative sessions that I have ever attended. So thank you very much to all the esteemed speakers. I think our students have got benefited. And some of the students were asking some other questions. Some were asking about ISRO, some were asking about the future of electronics, especially in the semiconductor industry. So for them, my answer is stay tuned with us. And very soon we will be organizing another such session where we will be focusing on that aspects of physics. So physics is the very basic, the very fundamental subject. And I think if you have the knowledge in physics, you can go to anywhere, whether it's academia, research, or industry. It will be able to flourish if you are working hard. So thank you very much to all the participants. On a Sunday afternoon, you are attending this. So thank you very much. All the
Just one
speakers,
thing,
thank you.
actually, before ending, I want to request Dr. Dhara. Do you want to say something about the quiz
Yes,
competition?
yes. More
Sure.
6 question has been posted, will be posted soon in Facebook link. Please go there and answer in comment sections. We will go through the comments and very soon we will post the result in Facebook itself. And also we will send the mail to each and every winners through, about your award and all, and we can call also. We will request to visit our campus. It will be nice to meet you physically. All are invited, all the participants are invited in our campus. So please keep your eyes on our Facebook page so that you can get your results soon. Thank you so much for the participations.
So much, everyone.
Thank you.
So let's
Thank you for
Thank you
inviting.
all.
Thank you so much.
Thank you. Bye.
Bye bye.